Here we've got a truck of mass 4,200 kilograms pulling a boat on a trailer with a combined mass of 1,500 kilograms. The hitch in between the truck and the boat is under some tension, which is why the boat accelerates with the truck. Now, once again, we're going to look at the entire system, construct a free body diagram, come up with an equation of motion, and then we're going to look at the individual masses and repeat the process. Looking at the entire system, let's label all our forces. Well, the boat and the trailer has a force of gravity that'll be straight down. And since I've labeled the mass of the boat trailer MB, I'll call this force of gravity boat, force of gravity B. The truck also has a force of gravity down, which we'll call force of gravity T, since I've labeled the mass of the truck MT. They're both resting on a surface. We know that neither the boat nor the truck are moving vertically, so there must be a counter force, which is the squeeze of the road on the tires, which we call the normal force. So there'll be a normal force up acting on the truck, equal and opposite to FGT. We'll call that F normal T. And there's a normal force acting on the boat, equal and opposite to FGB, F normal B. Now all those green vectors, all those vertical vectors cancel each other off, otherwise the system would move vertically. It would accelerate vertically, which we know it can't do. So let's do the horizontal forces in red or pink. Now there's no friction acting on either mass. It's not stated in the question, so we're not going to worry about friction. So let's just label the forces that are actually present. You can think of this hitch like a rope. It's under some tension. So as far as the boat's concerned, that trailer is being pulled to the right with a tension force, which we'll label FT. Now, same rope, same tension, pulls back on the truck. Newton's third law says they're equal and opposite. So FT also pulls back on the truck. Now, the truck is exerting a forward force from the wheels turning into the pavement. And that forward applied force is 3,400 newtons. So there's F applied, and they give you the value. 3,400, I said 3,400. 34,000, newtons. Now let's construct our equation of motion. Now I don't worry about the green vectors. They all cancel each other out. So the driving forces are all these pink ones. So anything horizontal. So my net force for the entire system will be FT. We'll look at the first FT here, which is pointed to the right. It's going in the direction of the motion, so that's a positive contribution. The other tension opposes it, so it's negative. And then my applied force is positive because it's in the direction of your acceleration. Now once again, when I do the entire system, those two tension forces that connect the two masses cancel each other out. So I'm left with a fairly simple equation. My net force is MA, and that equals my applied force, which was 34,000 newtons. Now what do I put in for the mass? Now once again, I used all the masses in the question to come up with my equation of motion. So this should be my total mass. Now my total mass will be the mass of the boat and the trailer, which is 1,500 kilograms, added to the mass of the truck, which is 4,200 kilograms. So that's my mass, times A will equal 34,000 newtons. Now when I solve this for A, it'll simply be 34,000 divided by 1,500 plus 4,200, which is 5,700 kilograms. And when I do that, I get 5.96 meters per second squared. There's my acceleration of the system. Now if I round it off to 2 sig figs, I get my 6.0 meters per second squared answered that's displayed. So now we know the acceleration of the system. Let's look at the boat by itself. Now for the boat, I'm going to change colors here. We'll do it all in yellow. Now once again, the boat has a force of gravity down and a normal force up. And the only force that's driving the boat to the right is this tension force. So if I write my equation of motion for just the boat, it would be F net is simply Ft. FGB cancels F normal B. In other words, the vertical net force is 0. All I'm left with as a driving force is Ft. F net is ma, and since I'm only focused on the boat, that'll be the mass of the boat times A equals Ft. The mass of the boat is 1,500 kilograms. My acceleration we've already determined. Now I'm not going to take my rounded answer of 6.0. I'm going to leave a few sig figs here so I don't get any rounding errors. 5.96, and that will give me my tension force. And when I do that, I get a tension force of 8,940 newtons acting on the boat. Now when I round that off to 2 sig figs, I get 9.0 times 10 to the 3 newtons. Now let's look at the truck. Now I'll do the truck in blue so we can keep track. Now once again, the truck has a force of gravity down and a normal force that cancels it off because it's not moving vertically. It has an applied force acting to the right from the motor. We know the value of that. It's 34,000 newtons. And there's this tension force from the hitch pulling back on it. In other words, the inertia of that boat trailer system is pulling back on this truck. So I'm going to label that Ft. Same tension force, same hitch. Now, the vertical forces cancel. We're only focused on the horizontal driving forces. So in this case, my net force will be my applied force, which is positive, subtracted my tension. Net force is ma, and we're focusing on the truck, so it's the mass of the truck times A. My applied force is 34,000. And we want to subtract that from my tension. So when I solve this or isolate Ft by itself, it will be 34,000 minus ma, which is 34,000 minus just the mass of the truck, 4,200 kilograms, and we're going to use 5.96 for our acceleration. And when I do that, I get a tension force of 8,970 newtons. Now, it should be exactly the same because Newton's third law says they're identical. We do have a little bit of error. This one is 8,970, the other one is 8,940, but we can attribute that error to the fact that we actually still have a rounded acceleration. 5.96 was still rounded. If you'll look at your calculator originally, there was lots more decimals beyond that. If we kept every single decimal place, they would be identical. The main thing is when we do sig figs, we still get the same answer. 9.0 times 10 to the 3 newtons for the tension force acting on the truck.